All right, so yeah, can everybody see that on that screen?
Mm-hmm.
Okay. So we want to create a new library and then make some things happen.
Hello world and plug.
Yeah. So we want to create the new one, mix new, and we want a supervisor with this. So we want, what do you want to call this? Anybody have suggestions? What we want to name this project?
What's it gonna do?
I don't know.
Fast lane.
All right. Let's make it that an actual. No. All right. So someone four. Started using Emacs.
Oh, cool. Space Max, nice.
Yeah.
Yeah, I've been thinking about trying it out.
I still have things to do. So here we've got normal project stuff, right? This is all standard if you were to create mix new.
What is the supervisor add to it?
It's a supervisor to
Okay.
supervise children in your application.
Okay.
So yeah, if you have other things like workers or something that you want to run as ad hoc processes that should be restarted whenever they fail, you'd use a supervisor to manage those.
Okay.
So
In
this
this case, we'll put a cowboy in there, or
we can, yeah.
something else.
Like that's a good way to do it if you want the listener to start when your application starts. So a normal production thing, you'd probably want to do that, unless you plan on using the mix task to do that, which probably not the best idea, but so let's add what we need, and that is plug and cowboy. No. I want to make sure that these are in your applications too, just for consistency's sake. I don't know the thing, so. Wow. I don't know why I threw that in there. New server. All right. Mix compile. Just make sure we're good there.
And rebar.
Yeah. It's new remote server, so I install things from scratch.
It's a new what?
New remote server that I have.
Oh.
I haven't actually compiled anything on Elixir there, so. All right, so we have our stuff, and we've got that good to go.
Is it a whole 8-core server just to run Emacs?
Just one core. It's got like 3.5 gigs of RAM now. All right, let's go back to our project. Now, you can have everything in this one module, but what typically, I'm going to create a router, right? So we want to be able to route these requests that we get inbound. And you can put it in here, but I'll typically create a separate module for that. So like fastlane.router. But you, by all means, can throw this stuff wherever you want.
Mm-hmm.
It's just a small convention that I like to use so that I keep things nice and clean. So let's...
Clean code is good code.
Yeah, that's what I think. And let's call this router. All right, cool. We have a router.
Yeah.
We have our module. We've used the router module or the plug router module. Now with that, we get a few macros. We've got get, post, put, delete, all that normal stuff to match your HTTP methods. And then there's a generic one called match that can do pattern matching on multiple HTTP methods if you choose that, or I think you can do custom methods as well through the match macro. But the standard ones, get, post, all those, they use match essentially and on the back end anyway, so it doesn't matter. But
These do like wildcards and stuff.
yeah, you can do a wildcard match. We'll cover that. What we want is all right. So we expect this to handle the index request, right? Say, hey, whenever we get a request in to the index of our web app, we want to say hello and respond with a 200. That's simple enough. So let's try it. Let's see what happens.
How did you put router up into the plug?
Huh?
How did you hook router up into the plug?
So the plug router and plug builder, which it's built on top of, they auto create init and call functions for you. That they're overridable, but by default you don't need to define them unless you need to do something fancy.
Well, I mean, how do you tell where to start? Like if you had two different files that both had routers in them, how would it know which one it's going to use?
Well, that's what we're going to do.
Okay.
So right now we have to. Why is this in a new one? I don't need this in a new one. So by default, it doesn't do anything, right? So if we were to run this application and start it up, what? Oh no! Oh, well, that's why. Let's give it something, right? So something nice that doesn't really affect us.
That's weird.
What?
I thought a plug would have been defined because of the use.
No, the plug itself is defined, but there aren't any plugs inside of it, right? So there's no pipeline that's created, so it's going to complain. It's just using the router and the builder that it happens. I never actually tried to do that with nothing in it, so I was surprised at that. But
So it's somehow new because you said use plug router that
yeah, so it
you
creates
needed to implement a plug.
Well, yeah, because it creates that attribute, that plugs attribute at compile time, and since nothing got pushed to it, then it knows that nothing was. It was never that plug macro was never called. So it knows that there's nothing in your pipeline, so it doesn't know what to do. So
I thought the get would have been a plug.
the get is just a macro call that gets expanded into a function. With
I
a
thought that would have been like a function plug or something.
nope, just a regular function. There are other plugs that we'll cover that actually call that function, but we'll get there. We'll get there. You were saying how does plug know to call our router, right? We can have multiple routers. How do we know which one to start out? So we would use our adapter, right, to do this. So we want an HTTP listener, and here is where we're going to pass our router. So this is the entry point for our application, and we want to say, hey, when you start this listener, use this plug as the handler for all of the requests that come into this web server.
Okay.
All right, and then
The router is a plug?
Yes.
It has plugs inside of it.
Yes.
They're all plugs.
Yes.
Okay. I get that.
And then we can pass it options to both the underlying web server as well as the plug itself. So this last set of brackets is to the plug, and then this would be to the web server, from what, if I remember right. So if we run this, do they change? Oh, I might have mistyped too. There we go. I forgot an S. So we have a process running now. And if we come over and try and hit that, forgot my little tool that I use with that isn't installed.
HTTPS.
Yeah, I can't type, obviously. Thanks for catching that. All right, so nothing happened. What happened? What's going on? Let's come over here. Oh, look at that. Look at that. Response was neither sent nor sent from the connection. Well, that sucks.
I'm getting this error: module plug adapters Cowboy is not available.
Have you pulled in the plug library?
I guess I haven't.
That's the first step.
I've loaded Phoenix on this machine, but maybe that was a local. Would that have done it?
No, yeah, it's per project. So if you created a new project, the plug dependency would have to get added to that project.
Oh, okay.
Are you talking about the Phoenix mix archive? Is that what you installed? Because that'll just do your mix tasks.
What you're referring to is
Your mix.exs file?
The mix.exs file.
Yeah, so you want to add dependencies for both plug and Cowboy.
Yeah, I thought I did. Maybe I did it wrong.
And then did you do a mix deps.get to pull those into your project?
The second part of that tuple is supposed to be the version number, so it's a list of
tuples.
Yeah, you want me to pull mine up?
Okay.
I know they're not version number.
So we have in ours here, we've got plug, and we just want to target some
Okay.
version that's close to 1.0.
1.0. Okay.
This is bothering me.
So that's okay. Those are actually two different tuples.
Yes.
It's a list of tuples. Got it.
Yes.
All
Your
right.
dep should always be a list of tuples. So whenever you get that set up, you can save that file and go back to your console and do a mix deps.get, which will pull those dependencies into your project. And then when you pull up IEX and try and run that module's function, that plug adapters Cowboy, it will be available to you.
Okay.
As long as everything goes
Mix
right.
deps.get.
Yep.
And you must have already done that at some other point.
Yeah, I did it here.
Oh, you did? Okay, I missed that.
Yeah, it's okay. It happens. So coming back to our error, right? Looking at the message, our response was neither set nor sent from the connection. So it's really cryptic. And what that means is that in our router plug, we missed a step.
Mm-hmm.
Okay? So we come back to the code. Some reason the function that gets generated from this get macro call is not getting called. So when we actually want to send a response, we're not, because it's not getting called. And the reason that's happening is that we actually didn't include two vital plugs, two function plugs that are required for this plug to router module, right? So in order for it to work properly, we need to include these. So let's do that. One is, I think it's dispatch then match is what we want to do. So dispatch and match is the other. So these go together essentially. And what they do is that they select the appropriate route, quote unquote, that matches the incoming request. And then I think it is the other way around. So you match the incoming request and then dispatch the correct function to get called. And that's what these two do. Hopefully I have this order right. So that when the request comes in, what was happening before is that our plug was set up in a way that it would get called, but nothing would happen to the incoming connection. We're not modifying it and doing something so that it would have a response set on that connection, which is what we want to do. What was actually happening is that it was just coming through and then just passing back out because it wasn't getting any transformations applied to it.
The thing that makes sense to me here is like earlier it said there aren't any plugs defined, and like to me, if I were sort of naively making this, get would have been a plug, you know? So it would have only, you know, done something if the URL matched in that get part of it. And then there would be a plug, and then, but it's not. It's actually just it's generating like a routing table somewhere.
Yeah, it's just creating.
It's
It's essentially just creating a function with a bunch of pattern matching to match the request details. So like the HTTP method, the path, and all that jazz. And then that function doesn't actually gets called until match or dispatch, right? So that's those two together allow the request to get matched properly to the correct function body. And so we can come back.
What was the error?
It's right here. It's a response was neither sent nor set.
Okay.
There are different statuses for connections, and it defaults to unset. I think is what it defaults to, but you can basically set a connection but not send it. And then you can also send it or halt, all the jazz, which there's a lot of details around this. But essentially, if you don't send a response, none will get sent to a browser when a request comes in. All right, we do that again. All right, so we have the process running once more, and hopefully we get a response.
Cool.
Check that out. Now, so right now, all this does is respond on index. So if we add in like any sort of path,
You crashing it?
we get another crash, right? We have another exception thrown because we've exhausted our function clauses and there are none remaining that match. So this is a normal function clause matching error that you might see in normal code. That's because we have that same function. This do match is what actually gets generated. There's only one definition for that do match, and that's for matching the index route. We don't have like a fall through. We don't have anything that would, capture a slug or something from a request path. We don't have any of that because we haven't defined it yet. So before we get going more, let's do a fall through, and by using the match macro, we can do that. Match and underscore, we can get everything and just send a 404 saying we don't know where that is.
Yeah, I was actually wondering how to do this one day in Elixir. That's cool.
So we have our match macro generating a function that says, hey, whatever you've got left, let me have it and I'll take care of it. I usually use this as a not found handler to take care of everything else that's remaining. And then go from there. So whenever I start a project, it always has one route and a fall through that catches everything else. And this is good for your development because you don't have these random errors like this one, especially for like your favicon or requests that happen automatically from your browser. Like, why would you want this in your logs while you're trying to actually create an application? So once again, we kill this. create it again, come back over to our curl window, and now we just get a not found. Cool.
What's the precedence on that?
It's just the end from the request. That's just how curl's interpreting it. Since I don't have a new line character, in my response body, curl just says, "Oh hey, here's the end." It might be a little bit with my my shell too.
So that's curl not.
Yeah, this is not Elixir. It's my shell and curl happening. But yeah, if we come back to our session, look, we've got log messages from our log plug, and we say, hey, we got a 404 response that we sent in 1 millisecond, and they were trying to get the high endpoint. Well, that's nifty. We don't have any failures. We don't have any exceptions that are thrown. That is the gist, right? Everything we cover past this is just building on top of what we've just covered. So essentially we have a module that we've called Fastlane Router. And it brings in all of the stuff that comes with plug router. And that's all of the routing macros, plug builder, and plug builder's plug macros as well. And that's a few other things, but those are the big points. And we want to log all requests and specifically match and dispatch those so that when this plug gets called by our adapter, our do-match function, which is what gets generated from our get and match macros, actually gets called. So that we can actually send a response to the browser.
Which plug are you talking about that gets called from our
It's not a plug, so if we come back to here, we've got this this call to Cowboy's HTTP function.
Yep.
So we pass it our router, right?
Yep.
This function, it depends on the first argument being a plug, and it needs to have some sort of plug passed to it. Here we're passing our router, which is a plug.
Okay, our router is a plug.
Because when we use plug.router, it sets up 3 big things for us. All of the stuff that it imports, it creates a few plugs for us. It creates an init function and a call function that are both overridable, but it creates default ones that you can use, and it works perfect just as is. Now, those function definitions, init and call, allow our module to be adherent to the plug behavior, so that it has, the specification is those 2 functions on a module.
Okay.
And the plugged router module creates those for us, so that when we pass it to something like the Cowboy adapter's HTTP function, that when we pass it to there, we can just let it go, and then because of the behavior, it's known that those functions are going to be there, or should be there, so that when it gets called, it's going to call them in the right way, so that the function bodies of that call method that gets created actually lets something happen. And that something is essentially just calling a function, an anonymous function that gets added to the connection, and that gets added by using plug and match. So they match and then create an anonymous function that gets added to the connection and match, and then dispatch essentially just calls that. And if these don't happen, then no function gets called, and you've got nothing that happens. Yeah. All right. Before we get too in depth, I wanted to touch base on testing. Like, how do we test this stuff? Like, it's great to pull up a browser or a command line and actually hit it with an HTTP client, but we can do better, right? We're good devs. We like to test our code at least a little bit to make sure it works. So let us join in testing this application. All right. Let's format some stuff. Best thing. All right, so I just created a little bit to get us going. So what we want to do is test our index, right? We want to make sure that we get hello world back just as this starting point. Now, if we were to come over, let's go this, and run this, hopefully everything's good. I don't have any errors. We should see that we don't have any failing tests, but we haven't actually tested our router. We don't know if something can actually happen. Lucky for us that the plug library comes with a little helper module to help along with testing, make it a little nicer to do.
Is there like a testing server?
No. There is not a testing server, but there is a testing adapter that is used that essentially in the test environment you don't actually hit a real web server like Cowboy, but it does everything in memory. It's kind of like a mock server. So what we want to do first off is actually use that plug. So we've got that there. You might have noticed in the autocomplete we have a few functions that are provided for us by that. The biggest one that you're going to use most often is the con function. Now this is confusing because you'll have a struct name con, a function name con, and most likely a variable name con. Name them what you want, the variables, but your function and your struct will still be con. But I always just keep it the same because everywhere in plugland I always just use con for that. Long con. So this function is accept 2 or 3 arguments. The first is going to be the HTTP method that you want this request connection to be. The next is the path in which you want it to represent. And then the optional one is your request body. So by default it will be nil, but you can pass it either a binary or like a map or something. If you pass it a map, it will assume that your request is form data content type and set that in your request. But if you pass it just a binary of like encoded JSON or XML or whatever, you'll want to set that content type, the request content type, manually, so that if your web application is accepting that that connection, that request connection, that it knows how to parse that body. But here we're just doing a GET request, so it won't matter. Why is that there? So here we just want to do a GET request on index. GET request on index. And this function returns a plug connection struct. So past this call, you can just use all conveniences that you'll eventually learn about with dealing with connections to do that. So you can modify the request headers, set a few things here and there. Anything you might want to do in order to set up your test. It's pretty seamless. You're essentially just working with a struct. But here,
so that con will be a struct.
This one, yes. So that we're actually going to output this. To get us going to see what actually comes back. No. Excuse me. So we test this, we'll get this back, right? So this is what's created for us. As you see, it has some defaults in there that it just uses to let everything work as normal. But the key point that you want to look at is this. Check that out. We have not our cowboy adapter, but a test adapter,
Okay.
right? So in the test environment, like I was mentioning, it uses this as a way to do everything in memory and not actually have to spin up a process to do this. But there's a lot of data here in dealing with the request. A lot of it's fudged, but it's just nice to see. You'll eventually get very familiar with what's available here. There's a lot of stuff that's shared between the request and the response, but they're both in this one struct. They're both representative here. You have separate lists of headers for request and response, as well as the response body. There's also, I thought there was a body somewhere, but I forget. Anywho, if we come back to our tests, we're still not doing anything. We're not testing anything. So what we want to do is say, all right, we want to make sure that the status that comes back is 200. And wow, response boxy. Response body is hello world, right? This is what we set up in our router as our default, our index. Now, if we run this, we will see that everything fails. What happened, right? Connection status, which we expected it to be 200, is nil. That's all bad, right? What happened?
We haven't done anything.
Yahtzee, we haven't done anything. So by default, we don't know what we're calling, right? Like, our router hasn't been called.
Yeah.
Whereas before, when we were spinning
There
up
isn't a
the actual web server, we were saying, hey, Cowboy, here's my plug. Start up a new HTTP listener. And it did it, and that's how we got our requests in. But here in test land, we haven't done anything like that. We don't have anything that's calling our router as a plug to do anything useful. So in our next bit, that's what we want to do. We want to actually call that guy and do something with our fake request that we've got here. And call is what we want to do here. So we want to pass it the connection we already have. And let's just pass it an empty list right now for our options. We'll come back to that bit. But if we come and actually try and run our tests again, hey, there we go.
Did you need the first line with the con being equal to the request?
So this bit here is actually creating a new request, right? Our request connection. The next bit is using it. In the official plug docs, they'll separate out both of these separately, like I have it here. But typically what I do is I remove this and this. No. Get rid of that and make it look like this. I'm just creating a pipeline, which, as we all know, does the exact same thing. But you need that first line here. This function call is what creates that struct initially for you, and has all of that default information in the struct, so that when you pass it to your router, everything won't fail.
It just, I guess it feels a little backwards to how I would think about it. Like I would, instantiate the router and then put in the rest.
Yeah, see here you don't have to instantiate a router. It's just a regular function. So you don't have to worry about that. all you have to do is instantiate your request object, right?
Okay. And what is the call? The call is somehow implementing what's set up, so the request that's already set up.
So if we come back to our router, the use plug.router here, this line here, the macro that's called for that use statement, because it calls a macro, a using macro when it does that, that call generates a few functions for us. It generates match, it generates dispatch as function plugs, and then it also generates the init and call functions as well that implement our plug behavior. And so we haven't defined a call function in our module, but there's one created for us at compile time because of that use statement. So that when we come and actually call it, like here in our test, it's available for us to use because there's already a default for us. And that's why this works. And that's like, since it's following the behavior that's set up by the plug specification, everything that expects these functions to be available, since this is a plug, that they are available.
Okay. So we're defining a request and then sending it through.
Yep.
The call. Okay.
It's basically just calling a function at this point.
Yeah.
So the plug test module, all we're really using that for is this function, this con function. Everything else is just normal function calls with our modules.
Oh right, that's a test specific.
Yes.
Okay.
Yep. Now, here we've just passed in an empty list, right? That's all this is. Well, that's not cool. What if we actually did anything with our options? Like we actually have something on our init function that modifies the options that we pass to do some fanciness. Typically what you would want to do is set up an attribute, like ops or something, whatever you want to call it. And up here at the top of your module is you want to actually call your init method. What happened? What is going wrong? You want to call that init function and pass it whatever options you want to set up as defaults. So I can come in here and say, option A, that's going to be true. Bob, Tom, pass it whatever options you want to do in your tests, and let that set up so that this is all at compile time. You don't actually have to run through this every single test, but this is also more representative of what could happen in a real application, right? You don't always know how your plug is going to be set up and called. You don't know if it's, this is going to be a compile time thing where this init function is called at compile time, or if it's going to be runtime.
You don't know that?
Not always.
Oh.
Like typically with your this stuff, it's going to be at compile time. But writing just normal plug libraries that aren't necessarily an entire web application, it could be at compile time when your library is called, the init function is called, but it could be at runtime, it could be at compile time. Who knows?
What determines that?
It's use case, whatever else other libraries are using it.
Okay.
So it's all
So if it's
dependent.
compiling code and then it runs into a call for something.
Wait, it won't be the call that is run at compile time. It'll be that init function. The init function is what will be done at compile time,
Okay.
which is what we're doing here. We're creating this one attribute that we're getting the value from this init call.
Okay. So that's determining the fact that it's going to be done at compile time.
Yes.
The fact that
You've set up. We're doing it as an attribute.
Okay.
Attributes
Like
and
yeah.
compile time.
Okay.
So we're just forcing this to happen at compile
Oh,
time.
okay. It's the fact that it's an attribute,
Yeah.
not necessarily that you're using.
Correct. So if we wanted to
Okay.
do this at runtime, what we could do is take this and pass it here. and do this, and instead of, ooh, no, Emacs is so fast, that's why I can respond to my every keystroke. So we could remove this attribute, right? And it essentially does the same thing, but now the options are generated at runtime when that test is run. Whereas before, the options were only generated at compile time when this test module was generated. The usefulness is that your test will probably be faster if you use the attribute, because it'll only happen once, and you're bound to have more than one test.
Right.
So when your tests actually run, it'll just run through with that pre-calculated value that it got at compile time.
Fast tests or good tests?
CC. Because then you actually want to run them. Alright, so we come back here, let's just run this and make sure that everything's still copacetic. Alright, cool. So if you notice, when we run our tests, we actually get our logging messages too. So if we have anything logged, like our use of the plug, the logger plug, it still happens.
Because we incorporated that module.
Yeah.
Or that plug.
Yep.
Oh, okay, cool. So it's just working. Just kind of happens.
Yep, it just happens like normal. So we come back here. If we remove this and come back and try and run our tests again, the logging message will be away because there's nothing to log it to the logging.
So it would essentially log every activity in that.
Everything that went through that router, right? So the router is our plug, and if our request comes in, quote unquote, that hits our router, and we had that logger plug still in there, it will it'll log everything that comes through.
Would that be true in a module with regular function calls, or what is just regular function calls?
No, it won't log the stack trace, like the call stack trace. That it won't do, unless you created a plug that would do that. But no, it will just do the top level request. You can configure it just like normal to log certain metadata, like request ID, what have you, like to have that in the logs. But that would be up to you. So yeah.
And you're already getting the stack trace.
Yeah, and plus it's not necessary unless something goes bad, right? And you get that when something goes bad. All right, now, so this works as is. We come back over here to the presentation. We covered the big things that I wanted to cover, which is good. Is there anything that you guys want to take a look at while we're here?
Well, I'm kind of curious, how would you do a custom plug? How would you design a custom plug?
Okay, well, what do you want the plug to do?
Let's say replace a word from a sentence.
Okay, so like say instead of hello world, well, that would be weird because it would have to be in the request. Think of something you can do with the request.
Okay.
Because that's it. Essentially, we are using plugs as a way to transform a request into different forms.
Maybe you would give it a couple words that it would add to a sentence, like subject object.
Okay.
This is that, or something.
All right. So let's say instead of hello world, we want to get right. We want to get a name from some unknown map. Okay. Now, the connection struct has a few different ways of storing data. You've got assigns, which is your main one. This is what Phoenix, I think, uses when you pass a connection down through your action, right? Whatever gets left, whatever's in that the assigns property will get passed to your templates, and that's how you get access to that data in your templates, through that assigns map. You've got a private one too. Then there's like your session map that you have to fetch those. There are different ways, but this is the main one that you'll typically use. So what we want to do is get that information. So if we come back and we run our test, so this is going to fail. Hooray. Now the plug that we want to do, let's say, just create a function plug. We'll name it add name, and we'll define a function add name. All right, now what we want to do with any plug is to modify or transform our connection at that current point to do whatever it's trying to do. So on the slideshow, we have this function plug, and both of the function plug and the module plug, they both do the same thing, and all we're doing is putting a response content type on our response, right? We want to set anything that uses this plug to say, oh hey, this response I'm giving you is JSON, right? That's its one purpose. That's its sole purpose here, is to just change that content type. And it's just a way to do that. We're just modifying that connection. So the reason why I wanted to do something other than changing a word for another word, because that would be in the response body. It's a little trickier to do in terms of changing that. This is a more direct in what we're trying to accomplish. So here we want to add a name to our connection so that we can use it later in our route. So what we want.
Are we changing the response body? What's going on here?
We are down the road, but at this current point, we're not. All we're
Right.
doing is we're going to set a name on this. We're going to set some value in a map here in this connection.
Yeah.
But we're not affecting the response until it actually gets used. Oh, no.
Okay, I see.
So it doesn't get used until line 11, but we're setting it here in 19.
Mm-hmm.
Now this can be from anywhere. I'm just making a convoluted thing, but yeah. There's probably a nicer way to do this, but I'm drawing a blank. So what we want to do is we want to update our assigns value. That's the word I was looking for, value. That's a tricky word. So we want to update that, right? So, you know, I don't really care about doing something crazy. We're just going to say, hey,
So Emacs can do all that? It can
autocomplete.
function. Yeah.
Yeah, it's through
Oh.
Alchemist, which creates that the backend for company, which is the autocomplete
Okay.
plugin that I'm using. So Alchemist just says, hey, give me everything that starts with this from a running Erlang virtual machine,
Okay.
and then just it populates it like you would have in IEX. You can do the same thing in Vim, I think. There's a help Vim plugin or help X Vim plugin that essentially does the same thing. So the developer of Alchemist is trying to decouple the server library that he created from the Emacs plugin, so that it can be used in other editors and IDEs. And that's what that help X
Alchemist is
plug.
an Emacs package.
Yes. And so he's trying to pull out the server that it's actually an Elixir application that he's using. He's trying to pull that out and decouple that from the Emacs plug.
Is Alchemist made for Elixir?
Yeah, it was a specific application that he created,
Okay.
the Emacs developer created for this thing. So, yes. So we want to put a name somewhere, and we'll say, surprisingly, that our name is world, right? So hopefully this works. Oh, that's bad. So, anybody knows what I did?
Nope.
So all I'm doing is putting a name on the connection
Yeah.
and not the signs.
Oh, okay.
Yeah. Update. That's not what I want. This would work. There's a cleaner way of doing that, just brain farting. So essentially we just want to update that. And hopefully I didn't mess up anything. Hooray! Our test is now successfully running again.
Nice.
So what happened before is that we didn't have any kind of data in our assigns, so that when we went to use it in our get route, it was failing, right? So what we've done with our add name plug is that we've modified the connection from their request to add this data in there. So you'll see a lot of plugs that either modify how the request is coming in, or deal with the request, or they deal with the response by changing some headers or something similar, the way that the request is presented to the end client.
In your map update, so assigns is the key? Okay.
So if we,
so that's just a convention when using the connect struct.
no, that's actually something that's already defined on that struct.
Okay. Just automatically.
It's in its definition. So let me pull that up. So here's that module that defines the struct. And there's a lot of documentation here, but here's the actual definition for the struct here. So if we notice, assigns is defined as an empty map. That's its default value. And we have a lot of other stuff here that we can access and use later down the road in more involved applications. But this is why we use assigns as that key in the map update. It's because that's the key here. And so that we know that, hey, this is what is expected, and everything will be all right. And if we miskeyed that, it won't work. So if we come in here and say, all right, instead of assigns, we did assigns with just one S. And we try and run this, and things will fail. So structs, they have an added convenience on top of maps, in that the keys are checked, or this update function is actually doing the checking. So it's like, hey, this key doesn't exist in this struct, so I'm not going to do anything because it's not there. Since it doesn't exist, we would either have to create it by using like put or something, map.put, or have it already there on the struct, which in this case we can't redefine the struct, so that would be out there as an option. So, also, Alchemist does some other cool things. So, like, you can come in and say, I can run a test here.
Oh, cool. Nice.
So it has those built in.
Yeah.
I'm still
I wanna
learning it,
try
so
that
I always
out,
forget. So the whole, this part, the bottom menu, that's all Spacemacs. So it lets me filter down my options.
Did you use Emacs before using Spacemacs?
No, I tried, and it was horrible. I was a Vim user. Emacs is the worst thing ever. But things that it adds on top to let you work with your code, it's nice. Like everything's async, and it's a little
You
slow.
had
But
to deal with any like temp files?
yeah,
Yeah,
you can turn those off.
yeah, pretty easily.
But it's nice to have them just in case. I usually just add in lines that might get ignored, just to remove those.
Oh, okay.
But they're just like the backup files. They're created when you don't save a file. Once you save it, they'll go away. So as long as you have your buffers saved, there shouldn't be a problem. But yeah, it's not too bad. It's just like Vim. If Vim crashes, it's going to create a backup file, like a dump or a swap file is what they call it. It's the same thing.
Do you use evil mode?
Yeah, that's what Spacemacs is. Basically, their tagline is, the best editor is not Emacs or Vim; it's Vmax and Vim.
Oh, okay.
So the default configuration is to use Evil in Emacs with a bunch of other things that make it more Vim-like.
Nice.
But you have an option to do Emacs simulation too, or a hybrid between the two. But most people just use the Vim.
What
keyboards.
theme were you using?
Syntax coloring is Tomorrow Night 80s. Just because that's the only thing that I've liked, actually. But all the colors in the status bar are defaults. I haven't actually changed those. So yeah, we have a working plug application. We've tested it. There's a lot more that we can do with it, but yeah, there's just so many options. Why just choose one? All right, any other questions? You're being quiet.
He's just over there mumbling Tuple to himself.
Well, I guess I'm just wondering if I can plug one tuple with another.
Plug one tuple with another.
You mean like read them?
You can technically merge tuples. It's just a pain in the butt to do.
So that it would